fractions instead of plain numbers. Okay, so if I am dividing like bases, this is a little harder for me to go, where do you have more twos, the top or the bottom, if we've got fraction exponents. So let me actually use the rule. So what you do if you divide like bases, so both of the bases are 2, you subtract the exponents. So I would take the exponent on the top, which is 2/3, minus the exponent on the bottom, which is 1/3. This particular question is super nice for us because they have a common denominator. You do need a common denominator when you add or subtract fractions. So that might be a little bit of a challenge on a couple of these questions that we're going to do today to review adding and subtracting fractions, but otherwise it's not too bad. So this literally would just 2/3 minus 1/3 would be 1/3. And if you guys look at the directions here, it says leave your answer in what we call exponential form. So that means that you have an exponent. All right. The other ones we're going to put in radical form, so we're going to have some like a square root or a cube root or something like that. But if it says leave it in exponential form, that means you have an exponent. Okay, now this one will be a little trickier. So I'm going to multiply like bases. My bases are both 7, so we're good to go there. And if you multiply like bases, then we're going to add the exponents together. So I'm going to take 1/2 plus 3/8. The one really tricky part there, if I'm adding fractions or subtracting fractions, we do have to have a common denominator. So see if you guys remember how to do this. Like, how would I get a common denominator between 1/2 and 3/8? Or what would you do? Anybody remember? What do you think? For sure, yeah. We're just going to make the denominators match. This one, we could just do top and bottom by 4. This is like what we're doing with rationalizing, right? I'm just multiplying by 1, so we're not changing the value of that fraction. We're just manipulating it for our purposes. All right, so 4/8, would you guys, that's the same as a half, right? 4/8 is the same as a half, plus 3/8. Once I have a common denominator, then I can actually simplify that. So this would be 7 to the 7/8 power. Okay, now this is where it's going to get a little bit tricky. So these are not like bases. So I have a 2 here and a 16 here. Now I promise I'm not going to give you guys anything that you can't get to be a common base, but this is where that lovely little yellow piece of paper might come in a little bit handy. Okay, so I need to rewrite it so the bases are both the same. In this case, I think the base I'm going to have to use is 2. It depends on the question. You might have a couple different options, but in this case, I want them to both be 2. So I'm going to leave that first term, 2 to the 1/2, alone. Can anybody tell me how I could rewrite 16 as 2 to a power? Somebody say it again? How would I write 16 as 2 to some power? Like if you look at these, you guys see 16 with the, like here, these are powers of 2, right? So 4 is 2 squared, 8 is 2 to the 3rd, 16 is 2 to the 4th, 32 is 2 to the 5th. So whatever root that is, 2 to that power is that number. So that's what I'm going to do here. So 16 I'm going to rewrite as 2 to the 4th because I got to get like bases to be able to do this. Now, once I have that, this is going to be helpful to us. So this is 2 to the 1/2. Just using exponent properties. Power to a power, you don't need a common denominator here. Power to a power, you would multiply the exponents together. So this would be just 4, so I just wrote 4/1 times 3/4. Just multiply straight across the top, straight across the bottom. So you would get 12/4, which is actually going to mean this guy just has an exponent of 3. Okay, and then this is maybe a little bit annoying, but I'd have to write, so I would get a common denominator. So I'm going to do 1/2 plus 3. To get a common denominator, I'm just going to write the 3/1, and then we're just going to do top and bottom by 2. Sorry, I'm using a lot of space here. So this would be 1/2 plus 6 over 2. See if that makes, like, if I do 6 divided by 2, that goes back into 3. So that hopefully that makes sense to you. Once I've got that common denominator there, I can actually add those. So I know this is a lot of work, but this would be 2 to the 7 over 2 power. And actually, on any of these, if you guys do, this is not part of the test or quiz where you can't use your calculator. So if you wanted to do like on your calculator, do 1/2 plus 3, and then just do that math, enter, that'll give you 7 over 2 if you want to do that. If you want to do that on a scientific, I could show you how to get it from a mixed number to an improper fraction. But if you want to use your calculator to kind of speed the process up on any of these where you have to add or subtract the exponents, that is completely fine with me. Okay, so let's do this one. So I have 5 to the 1/3. Okay, I got to get the bases to be the same. Can you write 25 as 5 to a power? How could I write 25 as 5 to a power? 5 squared, perfect, yeah. All right, so this is really 5 squared, and then that has a little negative 1/3 there. Okay, to simplify what I just did to create my like bases, power to a power, you would multiply the exponents, so we would just have 2 times negative 1/3. That would literally just be negative 2/3. We'd go ahead and add those exponents together. Alright, so 1/3 minus 2/3 would be 5 to the negative 1/3 power, and then I know this is a little annoying, but if you guys remember, we're not allowed to have negative exponents, so I'd have to write that as 1 over 5 to the 1/3 power. Okay, and let's try one more. I tried to put some of these on here that are a little trickier with the exponents, with where you have to create a like base. With the variables, it's actually not as bad. All right, so this is a situation where I need to create a like base again. So I have a 3 on the top and I have a 27 on the bottom. Can anybody think of a way to rewrite 27 as 3 to a power? I won't give you anything that's not on that little yellow card. 27 is 3 to what power? Can you tell? 3 to the 3rd. Okay, so here's what I'm going to do. I have 3 to the 2/3 power. 27 is really 3 to the 3rd. And then that's to the negative 1/3 power. All right, so 3 to the 2/3. Now, power to a power, I'm just going to multiply the exponents there. In that situation, if you do 3 times negative 1, that would be negative 3 divided by 3. This is actually just going to be 3 to the negative first power on the bottom. If I do 3 times negative 1/3, that's negative 1. Okay, if you are dealing with a division problem, which I've got here, this would be 2/3. This is a little weird. It would be minus the negative 1. Or you could move the negative 1 to the top, whatever way you want to do that. And again, if you guys want to grab a calculator on these, I'm going to do 2/3 minus a negative 1 would really be plus 1. And then I'm just going to do my math enter real quick to convert that. So it'd be 3 to the 5/3 power. Those are like the hardest questions that you'd have to do because obviously it's a lot of work with fractions and it's creating like bases is the very tricky part to that. Is anybody having a question? Yeah. Oh, like right here, what I did here? Okay, so if you are dividing, you're supposed to subtract the exponents. So if I just left it alone like this, it'd be 2/3 minus a negative 1. Does that make sense? Like, where's another one that I did that was a fraction? The very first one. So like if I do this one, it's 2/3 minus 1/3. You subtract the exponents. This one just ended up with a negative exponent in the bottom, so that's why it was minus a negative. Does that make sense? The other thing you could do, you could actually just move it to the top, and then it would be like 3 to the 2/3 times 3 to the 1st, and you're going to add the exponents in that situation too. Yeah, sorry, that one's really tricky. She's got it. All right. If we do this one, we're going to do 5 6 plus 1/4, right? Multiply like basis. So this is just going to stay x. Just if you want, we can create a common denominator. I'm just going to use my calculator today because we don't have as much time. So 5 6 plus 1/4. And then I'm just going to hit math, enter, because I don't know what that is. 13 over 12 would be my exponent there. You could do it by hand, or if you want to use your calculator for these, that is completely fine with me. All right, now I have one more. This one's a little bit tricky. So when I have just plain numbers involved, I have an 8 and a 10 in front of both of these terms, you actually just go ahead and multiply the 8 and the 10. So this would be 80. And then I'm going to add the exponents on the letters that are the same. In this situation, you'd have negative 1/6 plus 5 6. Now for that guy, that actually already has a common denominator, so that's super nice for us. We don't have to do anything to get a common denominator. This would be 4 over 6. Negative 1 plus 5 would be 4. And then the only other thing I would tell you there, if you can actually reduce that exponent, that's completely legal. So 4/6 is really the same thing as 2/3. So I just reduce the fraction. So if that's something you can do to reduce the exponent's fraction, do that. And that'll be the simplified answer. Is any big question?
So if the number isn't connected to the exponent, you can multiply it?
Yep. Now, if I had like parentheses around the 8 and the x, then that mean 8 would go to that power too, but we don't have that there. So only the x is to the power in both of those terms. Otherwise, you just take the two numbers and multiply them because they're being multiplied. Excellent question. Okay, these are all exponential form. All right, now, this is radical form. And again, I think your little yellow piece of paper will be very useful here. So let's say I have x to a fraction, exponent, I have a over b. Here's how you convert it to radical form, and I just call this bottom out. All right, the bottom of the fraction, so it's b in my little example here, becomes the index of the root. So this would be the b root of x to the a power. All right, so the a is going to stay, whatever's in the top of the fraction is going to be an exponent on your variable, and whatever's in the bottom of the fraction is going to be the index of the root. Okay, so here's how this works. If I just do a number here, the 1/2 power, right? This would be bottom out, this would be the square root, which we really don't need to write the square root of 64, but I'm going to here. So this would be the square root of 64 to the first. In that situation, I will tell you the 1/2 power is just equal to a plain square root. If you have like a 1/3 as your exponent, that's the same thing as a cube root. It's like if you have 1/4, that's the 4th root. 1/5 would be the 5th root. So if I have 1 over and my exponent, that's just going to be whatever that root is. So 1/2 is really a square root. And then you all know square root of 64, I know off the top of your head. That would just be 8. Okay, now if I do this guy here, if I do bottom out, this would be the square root of 4 to the 3rd. Okay, if you're trying to simplify these, here's what I would tell you to do. Take the root first. So like, what's the square root of 4? 2. Okay. Heart palpitations. All right. So square root of 4 is 2, and then do the exponent. That'll make it a smaller number to work with. So do the root first, and then do the exponent. So square root of 4 is 2, and then I got to take that to the 3rd power. So actually, that answer is also 8. If you have a negative exponent, all right, really this just means 1 over 343 to the 1/3 power. All right, so I'm just going to still do that bottom out thing. So this would be the 3rd root of 343 to the 1st, which would just be the 3rd root of 343. Anybody remember the 3rd root of 343? 7. So this answer would just be 1/7. If you have a negative, these can be a little bit tricky. All right, so I'm going to do my bottom out. I can do the cube root. I can do the odd root, so cube root 3, of a negative number. That's okay. So what is the cube root of negative 8? Negative 2. Okay, now this is the super tricky part of this. Okay, so we took the root, right? That was negative 2. and then we're going to square it. What do I get if I square negative 2? Positive 4. All right, so that can happen in some of these questions. You might have like a negative and it might get canceled out. So I did a cube root, that gives me a negative 2, and then I'm going to square that. Okay, I just got a couple more just to help you guys kind of get the hang of doing this, and then we'll do it with some variables here. All right, so if I do my bottom out, this is the square root of 25 and then to the 3rd power. So do the root first. What's the square root of 25? 5, and then I'm going to take that to the 3rd power. What, you guys remember 5 to the 3rd? 125. There's my answer. And you will not get a problem where you can't take the root. Okay, so if you can't take the root, then either I mistyped it or you didn't do it quite right. All right, so bottom out, I'm going to do the 4th root of 16 to the 3rd. Okay, if it's a 4th or a 5th, you guys might not be super familiar with these numbers. So feel free to use that little yellow card. Anybody know the 4th root of 16? 2. So this is really 2. Then you take it to the 3rd power. 8 must be the number of the day because that's the answer to this question too. All right, negative number. So I'm going to do, this one you guys might not know. Okay, this is the 5th root of negative 32 to the 4th power. So I'm going to take the 5th root first. Does anybody, and maybe look at that little yellow sheet, does anybody know the 5th root of 32? It's 2. And I'm just, because this is negative 32, I'm just going to do a negative. Now, when I take that to the 4th power, that's going to cancel out the negative number to an even power. It's going to cancel that negative. So this answer is going to be 16. And then let me do one. Yeah, we have time. Well, I'm going to do one more here before lunch. Okay, so I would do, before I do the bottom out, let me just do exponent properties here. So this is 216. Power to a power, I would multiply the exponents. So 2 times negative 1/3 would just be negative 2/3. Now, don't think negative number when you have negative exponent, right? That just makes this into a fraction. So this is 1 over 216 to the 2/3 power. Now, if I do my little bottom out, I'm going to do the 3rd root of 216, and then we'll square it. Does anybody know 3rd root of 216? 6. So this is really 6, and then we have to square it, so 36. My answer, we're just going to make sure we put that in the bottom of a fraction, so it'd be 1 over 36. We're working with variables. So far we've just been doing with numbers, so you can actually simplify this. Sometimes you can simplify these farther, sometimes you can. It depends on the question. But we're just going to write these. These are in exponential form because you see each one has an exponent, and we're going to write it in radical form, which means I'm seeing like a square root or a cube root or something like that. So I'm just going to do my bottom out thing. So remember I told you on the front the 1/2 power is the same thing as the square root. So we could just do, if you wanted to write it like that, that's fine. Or if you want to just write square root of x, whatever's easier for you and making more sense as we're learning this. If I have a cube root, which is what I have when I have a 1/3 power, so x to the 1/3 bottom out, this would be the 3rd root of x to the 1st. Or you could just write 3rd root of x. This guy, I'm going to write both of these. So this would be bottom out 4th root of x to the 3rd. Okay, I'm going to show you kind of two things because I probably should have been showing you this with the numbers as well. So you can write it like this, or you can write it like 4th root of x and then like a cubed on the outside. Those are the same. I usually use this format, frankly, because it's less writing and I don't have to put parentheses in there. But you can do it like that as well. And then now the last one. This one's a little bit weird. Okay, so this would be the square root of x to the 3rd. This does not apply to any of the ones we've done so far. For this one, the exponent inside there is bigger than the index of the root. So that means to me that I could simplify that a little bit. So if you remember a little bit back to what we were doing, if I'm working with a square root, I'm just going to try to remove any perfect squares. So I'm going to take that x to the 3rd and I'm going to rewrite it as x squared times x so I can take out any perfect squares. If I can get an exponent that's divisible by 2, and out of 3 the biggest number that would be divisible by 2 would be 2, I can actually pull an x out in front. So it totally depends on the question, but some of these you might be able to take like a step farther and simplify just a tiny bit. That's only going to happen if the exponent under the radical is bigger than the index of the root. So if the number inside is bigger than the one outside, then you can simplify it just a little bit. Okay, now this example is literally backwards. So these are all in radical form. We're going to write them in exponential form. So I'm literally going to reverse the bottom out. So this will be c, and then the index of the root is the bottom of the fraction. Whatever's on the variable is the top of the fraction. So 4th root of c cubed would be the same as c to the 3/4 power. Okay, now inside or outside, this is kind of similar to this question that I wrote up here. There's kind of two different formats, but the index of the root is always the bottom of the fraction, and whatever's outside there, that's a 5, that's the top of the fraction. So that would be b to the 5/3 power in exponential form. The next one, I'm going to reverse my bottom out, so this would be 3/12. Now, if you get one like this, if that fraction is something you could reduce, like both of those guys are divisible by 3, you should reduce the fraction to get it simplified there. So if I reduce that, both divisible by 3, that's really x to the 1/4. Okay, now the next three look super similar, but they're not the same. All right, so if you have a product in here, so I have 6 times a to the 5th under a square root. Okay, I know this is really weird, but the 6 would just have an exponent of 1. Like I'm taking the square root of 6 there. So when I separate this, it would be 6 to the 1/2. And then for the a, I'm going to reverse that bottom out. It would be 5/2. And we wouldn't do anything else there because I don't have the same base. I have a 6 for one of the parts of that product and I have an a, but that would be two separate things. Now, if you have parentheses around the 6a, so this is, both of these pieces are being taken to the 5th power. This is a square root. This would be 6a to the 5/2 power. And I know they don't look like it, but if you have parentheses around this, these two are just two different ways to write the same problem. So since I have parentheses around this whole thing, this would also be 6a to the 5/2 power. But that first one is different because it does not have parentheses. So I have two different pieces there. All right, now my very last example, I'm just going to combine kind of numbers and variables here. So with the numbers, I'm going to do the whole bottom out thing that we did before. So I'm going to do here, this is going to be a square root, and then we're going to have 4x to the 3rd, y to the 6th, and then all that would be to the 3rd power. So what I might do, and it's totally up to you, if you want to go ahead and distribute that 3rd power, that might make this one a tiny bit easier to deal with. Like 4 to the 3rd would be 64. Now, power to a power, we haven't, I don't know if we've done any of these today. Multiply the exponent, so x to the 3rd would really be x to the 9th, and y to the 6th to the 3rd power would be y to the 18th. And then this is back to like earlier in the unit, just trying to break down a square root. For 64, I would totally leave that alone because that's a perfect square. If my variable is a perfect square, that means the exponent has to be divisible by the index of the root, which that's not going on here with the x, right? So 9 is not divisible by 2. So to break that apart, up to 9, the biggest number that would go into, or be divisible by 2 would be 8. So I would rewrite that as x to the 8th times x. X to the 8th would be a perfect square because I could divide that exponent. Y to the 18, I would leave that alone because that exponent's already divisible by 2. So square, this is a square root, 64, that would come out as an 8. X to the 8th would come out as x to the 4th. Y to the 18th would come out as y to the 9th. And then we'd have an x left underneath. So my answer there, we'd have 8x to the 4th, y to the 9th, and then we still just have 1x left under the square. Okay, this one, let me see here. This would be, I'm going to rewrite this as a fraction here in a second because I got a negative exponent. But if you have a product to a power, everybody in there gets that exponent. So this would be 16 to the negative 3/4. Power to a power, so that negative 8 to that negative 3/4, we'd actually multiply the exponents. In that situation, don't need a common denominator to multiply. Just straight across the top, that'd be 24. Straight across the bottom, that would be 4. The negatives are actually going to cancel, so that'll be a to the 6th power. Now, in terms of this one, we can't have a negative exponent, so I'm going to move this to the bottom of the fraction. So we'd have a to the 6th, and then that would be over 16 to the positive 3/4. Now, a to the 6th, you're not writing that in radical form because it's just to the 6th power. There's no bottom out to do there. You could do the first root of a to the 6th, but that wouldn't be anything. We could do 16 to the 3/4 to simplify that a little bit. That would be the 4th root of 16 to the 3rd, which I feel like we've done today. So 4th root of 16 is 2, and then to the 3rd power would actually, I feel like that's on every question. We had an 8 today. So this would be a to the 6th over 8. Just totally simplified there. And there's no radical form because all the radicals end up canceling out in that particular case. And then I have one more. So 243 to the 2/5. Now, power to a power, I'm going to multiply the exponents. So negative 10 times 2/5 is going to become negative 20 over 5. So I'd have x to the negative 4. So that's not going to be a radical, but we're going to put that in the bottom of the fraction. And then 20, positive 20, times 2/5 would be 40 over 5. So that would end up being y to the 8th. So we're not going to have any radicals with our variables there. I got to move this x to the 4th to the, I'm going to make a fraction, move that to the bottom. So I'd have that 243 to the 2/5, y to the 8th on the top, x to the 4th, well, I made a giant 4 there, on the bottom. The only other thing you could do there, let me see if I can make some space. I'm going to do the 5th root of 243 squared. I promise you, if you're doing anything with a number and you got to take a root like that, it will be on this list. So if you grab your lovely little yellow sheet, the 5th root of 243, if you look at the 5th root, that's the 5th column. 243 is the 3rd one down. So the 5th root of 243 would be 3, and then we would square that. So the 5th root of 243 squared, this is actually 9. So my final answer, just on the top, we'd have 9 y to the 8th, and then x to the 4th. Okay. Does anybody have any questions?
So why on the first one did you just